we know has a sum if it converges, right? So a geometric series converges if it has a sum. How do we find the sum of a geometric series? A over 1 minus r, as long as a is the first term, right? So if it starts at 0, a will be the first term, right? As long as you're thinking about a as the first term, okay? So let's look at the geometric series here. And let's look at what happens if a is 1 and r is x. So what would f of x be? If a is 1 and r is x. Oh, sorry, this is far away. There we go. Yeah. Okay, so we're plugging in a and r. So let's write out the first couple terms. What will the first term be when we plug in n equals 0? 1, which is a. What will the second term be? 1 times x to the first power, so x. What will the third term be? Or second, yeah, third term, whatever we're on. Plug in 2 and you'll get x squared. Plug in 3 and you get what? X cubed. Blah, 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 blah. So our nth term or our general term is x to the n, right? So if you do a geometric series where a is 1 and r is x, you now have a power series, right? Because it's now a power of x. So this is an infinite polynomial. So when will this converge? When will this converge? When I plug in x equals 5, will this converge? What is x? It's the radius, right? It's r. So when does a geometric series converge? When the absolute value of r is what? Less than 1. So if you plug in x, will this converge? X equals 5, will this converge? No. If you plug in x equals 1/2, will it converge? What about negative 1/2? Yes, right? So as long as the absolute value of x is less than 1, this will converge. So if the absolute value of x is less than 1, this will converge and this will have a sum. How do I find the sum of a geometric series? A over 1 minus r. What's a here, or the first term? 1. First term is a, which is 1, or first term is 1, over 1 minus r. What's r here? X. So this geometric power series, this infinite polynomial, 1 plus x squared plus x cubed plus x to the third plus x to the fourth, if you do that all the way to infinity and you draw the graph of that, it's simply going to be the function 1 over 1 minus x. Because that's the sum of a convergent geometric series. Okay? As long as x is less than 1. Okay? So if you are talking about that part, then x, this will be that. Okay? So we can write geometric series as functions. So let's do that for this one. This is also a geometric power series. What is a here? What's a here? 3. What's r here? X. They tell us the absolute value of x is less than 1. What does that tell me about my series? It converges. So this tells me that it converges. So if it converges, then it has a sum. Let's look at just what the first couple terms are going to be, just for kicks. What's the first term going to be when n is 0? 3. Should be 3 because we said a was 3. Then what's the next term going to be when you plug in 1? 3x. Plug in 2, 3x squared. Plug in 3, 3x cubed. So the only difference between this one and this one is the a, right? A here was 1. Now a is 3, right? But this guy has a sum because the absolute value of x is less than 1. What will the sum of this be? How do we find the sum of a geometric series? A over 1 minus r. What's A? 3. What's r? What's that r? X. So what's the sum of this going to be? 3 over what? 1 minus x. So if you see a function that is written like this, that is a geometric power series, right? That's from algebra 2, that's just a good old function. 3 over 1 minus x. That's just a rational function, right? But you can also write that as a geometric power series if it has that form, okay? So we can write functions that look like this as a geometric power series, okay? So we're going to go backwards now. I'm going to give you a function, and we're going to write the geometric power series. So let's look at 4 over x plus 2. This looks a little bit different than 3 over 1 minus x and 1 over 1 minus x. How is this different? Why does that not look like perfectly the sum of a geometric series? X is positive, first of all, right? And it's switched in order, right? And then what is this supposed to be? If you're looking at the sum of a geometric series, it's A over what? 1 minus r, right? So if you want that form of a geometric sum, it's going to be some number in the top over 1 minus r, right? Does this have a 1 minus something here? No. So let's make it have that. Let's manipulate it so that we can adjust it. So we'll start with 4 over x plus 2, but I will rewrite it as 2 plus x. How can I turn that into a 1? Divide it all by 2 in the bottom, right? So factor out a 2 out of the bottom. That will give me a 1 there, right? So let's factor out a 2 out of the bottom, i.e. factor out 1/2. So then I'll have 1 plus what? If I factor out a 1/2 out. X over 2, good. And then I can make that a minus if I just make it a double negative. Now from here, sometimes you'll see people write the A in the top part. Other times they'll write it in front. So you can either pull out the 4 with the 2 and write this as 4 halves over 1 minus, like that. Or you can put the 1/2, multiply the top by 1/2 and put it in there. You'll see it both ways. And it's kind of just personal preference. Whether you want the A to be out in front or whether you want the A to be in the top, right? It's still a constant divided by 1 minus r. So that's still the sum of a geometric series. So in this form now, you can tell me what A and R are. What is A going to be? 2. 4 divided by 2 is 2. And what's R going to be? Negative x over 2, right? Because you have A over 1 minus R, right? So this is a geometric series. We can write this as a geometric series when A is 2 and R is negative x over 2. Any questions about how we just got it into that form? Just some algebra manipulation. All right, so now let us write it as a geometric series. So if A, so our original starting function was 4 over 2 plus x. And we're writing it as a geometric series. What was A? 2. What was R? Negative x over 2 to the n, right? That's a standard geometric series. A times R to the n. Geometric power series. Now, a lot of times you will see it kind of simplified. It won't necessarily look like this. So let's talk about kind of how to manipulate this. Well, we can, first of all, this 2 in the front is to the first power. We can break up the negative x to the n into negative 1 to the n and x to the n. And then we'll also have a 2 to the n in the bottom, right? Because all of this is raised to the nth power. Negative 1, x, and 2. A lot of times we separate out the negative 1 because that's like the alternating part. And then these 2's are going to connect, right? So really, if there's n 2's in the bottom, there will be 1 less 2 in the bottom. So often we will see this simplified as 2 to the n minus 1, subtracting that exponent and moving that 2 to the 1 down to the bottom. So this is probably how you would see this written rather than in this original form, the way that we just wrote it. But you might see it both ways. So now it said write out the first 4 terms and the general term. So we wrote out the general term. Have we written out the first 4 terms of the series? No. So we need to write out the first 4 terms, and then we'll find the interval of convergence, okay? So it wants first 4 terms, the general term, and the interval of convergence. So one option, just start plugging in values, right? 0, 1, 2, 3, 4. But remember, you also, that's one option. The other option is to remember to look at this guy here, right? What we wrote, this guy here is a version of 1 over 1 minus x, right? So you could also use this, multiply by 4 halves, or 2, and then what would we be plugging in here for x, if we wanted to use that? What would we be plugging in for x? Negative x over 2. So you could just plug negative x over 2 in for that, and then multiply by 2 to get your terms, or you could plug in n equals 0, n equals 1, n equals 2. You're going to get the same thing either way. So let's do that. I'm actually going to use this version for plugging in the term. So plug in n equals 0, and what do we get? 2. Plug in n equals 1, and we get 2 times negative x over 2 to the 1. Plug in 2, and we get 2 times negative x over 2 to the 2. How many terms am I supposed to write out? How many have I done? 3, so 1 more. And notice how this is exactly the same thing you would get if you took this and plugged in negative x over 2, right, into each of those, and then just multiplied by 2, right? Because this is 2 times 1 over 1 minus plugging in that, right? So it's literally the same thing you would get if you multiply that by 2. So it's kind of a matter of which perspective makes the most sense. Let's simplify this a little bit, though, and make it look a little bit more pretty. So 4 over 2 plus x, which is our geometric power series, which we wrote in a more simplified version. So that's the way we first wrote it, and then that's how we simplified it. And then if we simplify these first couple terms here, we'll have 2. The 2's will cancel here, right? So we'll just have minus x. We'll have positive x squared, right, when we square a negative. And then you'll have 2 squared in the bottom, but one of those 2's will cancel out. So now you'll have positive x squared over 2 to the first power, because one of those 2's will cancel out with that 2. And then cube a negative, and you get a negative still. So you'll have negative x cubed. You'll have 2 cubes in the bottom, but one of those 2's will cancel out with that 2 in the top. So now you'll have 2 squared, dot, dot, dot. So that's the first four terms and the general term, either one of these two forms. In the simplified term here, you can kind of see the pattern a little bit more of the simplified version, right? Because this is your alternating positive, negative. You have x to the n power, so here's x to the 0, here's x to the 1, x to the second, x to the third, and then 2 is always 1, the power of the 2 is always 1 less than your n, right? So you can kind of see the simplified version in the simplified terms. So, general term, first four terms, and now they asked us for the interval of convergence, right? What kind of series is this? Geometric. When does a geometric series converge? When the absolute value of r is, what's our r here? Negative x over 2, right? Wasn't our r here negative x over 2? So this will converge when the absolute value of negative x over 2 is less than 1. So now we'll just solve this inequality. The absolute value will make that positive. So when x over 2 is less than 1 or greater than negative 1, so our interval of convergence will be negative 2 to 2. When x, if you multiply by 2, right, you'll get negative 2 to 2. Do I need to check my endpoints? No. What kind is this? Geometric. When you plug in negative 2 in here for r, what are you going to get? 1, negative 1, right? And what does the geometric do? Whenever r is 1 or negative 1, diverges. So it will not converge at those endpoints, so you don't need to check them. Or we just checked them in our heads. Any questions about that example? Okay, let's do one more, and then I will have you do one on your own. So you can kind of take two approaches here, same way that we just did the last one. First of all, we should see right away that this looks kind of like a geometric series sum, right? In fact, this might even be more like a geometric series sum than the last one. Because can you tell me what A is just looking at this? So remember, what's the sum of a geometric series? What's the formula? What's the formula? How do we find the sum of a geometric series? A over 1 minus r, right? Or first term over 1 minus r. So what's the first term? 2x squared, right? What's r? X squared. You don't even have to manipulate this one, right? It's already in the number something over 1 minus r form, right? So you can already tell me right away here that A is 2x squared and r is equal to x squared. Because it already looks like this. You could also think of it as 2x squared times 1 over 1 minus x squared. So we're supposed to write out the first four terms, the general term, and then state the interval of convergence. So let's start with the general term. A is 2x squared. R is x squared. So A times r to the n is your general form for a geometric series. Now to write the first four terms, you can take your options. Start plugging in 0, 1, 2, and 3. Or you can think about what 1 over 1 minus x looks like. Remember, this is the standard geometric series, 1 plus x squared plus x cubed. So if you want to write out the first four terms, this is almost the same. What would we be plugging in here for x? X squared, and then you would just multiply by 2x squared, right? And so if you want to do that instead, you could take each term, plug in x squared in for x, and then multiply by 2x squared. Or you can just start plugging in 0. So if we plug in 0, we'll have 2x squared times x squared to the 0 plus 2x squared times x squared to the first plus 2x squared times x squared to the third plus 2x squared times x squared to the fourth. What did I do? I jumped one. What did I skip? I skipped 2. Boop, boop, boop. 1, 2 comes before 3. Dot, dot, dot. That's the first 4 terms, right? 0, 1, 2, 3. Yep. So now let's simplify that, and we'll simplify the general form as well. So this will be 2x squared times x to the 2n, which we can really write as x to the 2n plus 2. So let's rewrite that as x to the 2n plus 2. And then this will be 2x squared, 2x to the fourth, x squared squared will be x to the fourth times x squared will be x to the sixth. What do I do with these exponents? Do I add them or do I multiply them? Multiply, right? This one, it doesn't matter because 2 plus 2 is 4 and 2 times 2 is 4, right? But what should this be? X to the 6th times x squared will be x to the 8th. So we wrote out the general term. We wrote out the first 4 terms. What else did it ask us for? Interval of convergence. How do I find the interval of convergence for the geometric series? When does it converge? When the absolute value of what is less than 1. What's r here? So if I want to find the interval of convergence, I want to know when is the absolute value of x squared less than 1. Well, take the square root of 1, and that will be when the absolute value of x is less than the square root of 1. Or just 1, right? So it'll be absolute value of x is less than 1, which is the interval -1 to 1, if you make the inequality. If you need to see the inequality. Do I need to check my endpoints? This is a geometric power series, right? If you plug in -1 and 1 in for x, you're going to get r is more than -1. It diverges at the endpoints, right? This is a geometric power series. That's what we were using to do this. So it's geometric, so you do not need to worry about the endpoints. Any questions about 2b? All right, do 2c on your own. All right, I'm going to go over this one real quickly. So in general, we want this to be in the a over 1 minus r form to see what a and r are. If you factor out a 1/3, you will get 1 over 1, and then you can make this a double negative at the same time, x cubed over 3. And so from there, we can tell that a is equal to 1/3, and r is equal to negative x cubed over 3. So then you can make your general term. So you'll have 1/3 times negative x to the third over 3 to the n, a times r to the n. And then it's up to you whether you want to just start plugging in 0, 1, 2, and 3 into that to find your first couple terms, or whether you want to base it off of this guy, plugging in negative x cubed over 3 into this guy for x, and then multiplying by 1/3, you'll get the same answer. Okay, so if you do the first couple terms, you'll get 1/3 will be the first term when you plug in n equals 0, and then you'll get 1/3 negative x cubed over 3 to the 1, and then 1/3 negative x cubed over 3 to the 2. And we're supposed to do the first 4, so we'll do one more. And then let's go ahead and simplify this as well. When you simplify the original, you can pull out that negative 1 to the n. You'll have x to the 3n, and then we'll have 3n plus 1 for the power of 3, right? Because you'll have 3 to the n plus another 3, right? So times 3 to the 1, so you always have one more 3. And then you can see that in your terms if you simplify your terms, because you'll see 1/3, we'll get a negative x cubed over 9, a positive x cubed over, or I'll write it in the powers of 3, just for pattern's sake. And then we'll have a 3 squared times another 3 will be cubed. And then our last one will be a negative, because the cube and negative, and that'll be 9th power over, I know it went away, I'll put it back up here in a second, 3 to the 4th. Did you have that simplified for yours? And are we okay from going from here to here? This manipulation, any questions about this? Because you're going to see it this way, right? Like on multiple choice question, they won't write it this way. They'll write it this way.
Why is it plus x cubed over 3 cubed?
Oh, did I skip one here? Oh, yeah, you're right. I didn't multiply. Good call. Thank you. Yeah, that doesn't make sense with the pattern either. Something's off. And you can see the pattern here, right? Because here these are all multiples of 3 now, right? And how do we write multiples of 3? 3 times n, right? Plug in 0 and you'll get a 0 power. Plug in 1, you get 3. Plug in 2, you get 6. Plug in 3, you get 9, right? And then 3 is always one more than the n that we plugged in, right? So this is 3 to the 1, 3, 2, 3, and 4. So you can see that in the simplified version. And then lastly, we need the interval of convergence. What is our r here? Negative x cubed over 3, so we want that to be less than 1. Absolute value will make the negative go away, so we'll have x cubed over 3 is less than 1. Multiply by 3, and you get absolute value of x cubed is less than 3. So the absolute value of x will be less than the cube root of 3. Or if you write it as an interval, that way, so your interval of convergence is this guy right here. I'm not going to write it in interval notation this time, just because I don't feel like it. We'll leave it in that notation. Do we need to check endpoints? No. Geometric series is going to diverge here. Because you plug those in, you'll get 1 for r, right?